Hey guys, in this video we will be going to discuss about the PKI infrastructure. In Hyperledger Fabric, PKI is the backbone of the blockchain network. So basically PKI is widely used in the Hyperledger Fabric for interaction between various entities that we have like peers, orderers, and even in the transactions as well. These PKI infrastructure is heavily used. So let's discuss what is PKI. So PKI stands for Public Key Infrastructure and it describes a set of procedures and rules that how to store, issue, and revoke the certificate and manage the public keys. So PKI is all about managing the public and private keys as well as the digital certificate and the entire life cycle, like issuing the certificates, then storing them, revoking them, etc. So let's discuss about the symmetric cryptography. So symmetric cryptography is also known as secret key or shared key cryptography, where we have a single key which is used for encrypting and decrypting the data. And this is faster than asymmetric cryptography because in that cryptography we have to deal with multiple keys and as well as the processes are somewhat different. But in this symmetric cryptography, we have only one key and that key is used for both encrypting as well as decrypting the data. And if you take a look at the diagram as well, that here we have the plain text and then we are applying the encryption algorithm using that secret key and then we get a ciphertext, and after that at the decryption side we are using that same secret key to decrypt the data and get the plain text. And the same key is shared on both the sides, like on the encrypting side or on the sender side, and the same key is used on the receiver side as well. They both share the same key in order to encrypt or decrypt the data. Now let's discuss on the asymmetric cryptography. So in asymmetric cryptography, we have a pair of keys that are used for encrypting and decrypting the data as well as signing up the data. And these keys are linked to each other through mathematical equations. And in asymmetric cryptography, we have two types of keys. The first is the private key and the second one is the public key. The private key is kept private with oneself and the public key can be distributed with anyone. And in this way, these keys are shared among the various participants that are taking part in sending and receiving of the data. So here we have the diagrammatic explanation of cryptography. On the left hand side, at the encryption phase, we are using the public key to encrypt the data, and then on the decryption side, we are using the secret key to decrypt the data. And if we have to understand this in the scenario of sender and receiver, so sender is going to use the public key of the receiver to encrypt the data, and then receiver can use its private key to decrypt the data. So now let's discuss about the signing part, that how signing happens using the asymmetric cryptography. So first of all, at the sender side, the data is hashed and then and that hash is encrypted with the private key, and as a result digital signature is generated, and after that data and the digital signature both are sent to the receiver side. And on the receiver side, receiver receives this digitally signed data, and after that the hash is calculated of the data, and at the same time the signature is also decrypted using the public key, and the result is compared with the hash of the data that we calculate in the step 2. And if both the hash matches, then that means that it is a signed data and we are receiving it from a verified source. So let's understand the scenario using this example. So here Alice want to send some quarterly profit statements to the Bob, and we are here using the signing method, and here basically we are going to sign the data and send it to Bob. So first of all, this data is passed to the hashing algorithm, and after that the hash is calculated using that hashing algorithm. And once the hash is calculated, that hash is encrypted, the data hash is encrypted using the private key of the Alice, and as a result of this encryption we get a digital signature. So the digital signature is formed and then data is sent along with this digital signature. So at this phase you can see that we are having data as well as the digital signature, and this complete piece of information is sent to the Bob. And on the receiving side, where the Bob received this data, Bob is going to do two steps simultaneously, parallelly. So what he's going to do, he's going to pass the data to the hashing algorithm and going to get the hash, and simultaneously Bob is also going to use the Alice's public key and decrypt the data. So once he just try to decrypt the data, he will going to get a hash, and after this both the hashes are compared, like this data hash that is retrieved through the decryption part and as well as that hash that we received as a result of the hashing, both are compared, and if both the hashes matches, then which means that the message has not been modified. But if they don't match, which means that the message has been modified. So now let's discuss what we cannot do using the asymmetric cryptography. We cannot use the same public key to encrypt and decrypt the data, as well as we cannot use the private key, the same private key to encrypt the data as well as the decrypt the data. So this is the summary, like what we have seen so far with the asymmetric cryptography, that encryption with private key must use the public key and vice versa. Like if we are encrypting up the data using the public key, then we have to use the private key in order to decrypt the data. As well as the hash of the data, when passed through an encryption algorithm using the private key, is called a digital signature. So basically the digital signature is formed as a result of hash of data plus encryption. So now let's understand the elements of PKI. And in Hyperledger Fabric, these PKI is like the bare bone of the whole blockchain system. This PKI is like heavily used in the blockchain to maintain the security among all the different components that we have in the fabric. So basically the first component is the digital signature, and then the second component is the public and the private key. The third is the certificate authority, and the fourth one is the certification revocation list. And these PKI elements are used to maintain the life cycle of the digital identities, like the digital certificates, and as well as the private and the public keys of the identities. Let's discuss about the digital certificates. So digital certificate contains an identifier that identify an entity and ties ownership to a public key, which means the digital certificate contains the information about an entity, and the identifier that are kept in the digital signature are called subject. As well as, apart from having subject, digital certificate contain a hell lot of information. They contain the public key of the entity, they contain the expiry date of those digital certificate, they contain the identity of who the issuer was, and also these digital certificate are issued by a certificate authority. And also digital signature can be used for encryption as well as verifying the signatures. So here, this is one of the certificate that I took from the Hyperledger Fabric, and basically I just wanted to show you some details. That's why like I put that certificate here. So here, this has basically, this certificate contains the issuer data, and here you can see that we have the details of the issuer, like who issued this certificate, and after that we have some validity information. Here we can see that this certificate is going to expire by 30 October 2022, and as well as the subject, which is the like main component of this digital certificate, is this one, which basically contains the information related to the entity to whom this digital certificate issued. And here we have this common name attribute, this one, which is CN, and basically this contains the name of the entity to whom this certificate is issued, and as well as we have the public key of the user to whom this certificate is being issued. Now let's discuss about the certificate authority. So certificate authority is an entity which issues and revokes of the certificate, and these certificate authority are widely used in the Hyperledger Fabric. They are used for verifying those certificates, and certificate authority issues the certificate to the different entities that request for the certificate. Certificate authority has also its own certificates that are created when the certificate authority is bootstrapped, as well as it has its own public key and the private key, and it issues certificate to the other entities. Also, we have a chain of certificate authorities, like we can have the root certificate, then we can have intermediate certificate, and this forms a chain of trust that we can see here, that we have root certificates, and after that we have intermediate certificates, we have multiple intermediate certificates, and basically this intermediate certificates get its certificates from the root certificate authority, and after that this intermediate certificate authority can issue certificates to the entities who are requesting for the certificates. And here also we can see that these are the certificates that are issued by intermediate CA1, and these are the certificates that are issued by intermediate CA2, and these are the certificates which are issued by intermediate CA3. So basically we can have a chain of certificates, and here we can see that this intermediate certificate authority, which is ICA1, gets its certificate from issued from this root certificate authority, and then this intermediate certificate authority 2, ICA2, gets its certificate from ICA1, And after that, this intermediate certificate authority 3, IC3, gets its certificate from ICA2. And basically this forms a chain of trust. And the last element of this PKI infrastructure is the certificate revocation list. So basically this is a list of references of the certificate that has been revoked by the CA. And whenever any party wants to verify the certificate of any other entity, it first checks the certification revocation list of that particular CA to make sure that the certificate has not been revoked. And the certification revocation is quite different from the certificate expiry. Revoked certificate are not expired, and they are basically revoked, and their references are put into a CRL, which is also called as certificate revocation list, and they are a fully valid certificate. And if we want to verify the certificate of any entity, we can directly go and check the CRL. And if that certificate is not present in the CRL, that means that that certificate is valid. But if the serial number of that certificate is present in the CRL, that means that the certificate has been revoked. And we can kind of depict this in this example. Like here, we are checking up the CRL for this certificate, which is a valid entity, and we found it to be valid. And but for this identity where the certificate is revoked, the reference is kept onto this revocation list, and that can be kind of verified through this list. And since this certificate is present inside this list, which means that that this certificate cannot be used anymore longer. Now let's discuss about the certificate signing request. So certificates are issued using this certificate signing request, or in the short we call this as CSR. And basically to get the certificate, we have to follow certain step at the entity level as well as the CE level. So let's discuss first about the steps or measures that we need to follow at the entity level. So entity has its public key and the private key, and basically entity issues a CSR request with the subject, and the subject contain the information about that entity, and then it attaches its public key to that CSR, and then sign the certificate with its private key. After that, the CSR is sent to the certificate authority, and the certificate authority checks the digital signature that are attached to the public key in the CSR, and basically it creates a certificate using the CSR and adds the information about the issuer that we saw in the digital certificate, that there is some information about the issuer as well, and then sign that certificate using its own private key. So we can visualize this using this example here. So here we have one client, and basically that client has its own private key and public key that are stored into its private key store. Client issues a CSR request, and in that CSR request it attaches its public key as well as the subject identifier, like its name and other details as well. And then it submits that CSR to the certificate authority, and after that certificate authority issues a certificate to that entity, and after that CA issues the certificate to that entity, and after that that certificate are sent back to the client. So this was pretty much it for this video. Hope you liked the video. If you like this video, then please give a thumbs up and subscribe to the channel, and I will see you in the next one.